Okay, so now we want to finish solving this problem right here. So all we're left to do is to figure out what the shock location is. All right. So the way that we have it here is not in what's called conservative form. I don't know if this has a name, but this form right here is the form. This form of the equation is the form that we have to have it in to be able to do the characteristics, but to be able to apply the Rankine-Huganoot condition, the RH condition, which is what I'll call it from now on, because I just have problems, embarrassingly, have problems with the French names. Sorry. To apply the RH condition, we're going to have to be able to write this in conservative form. And I will just remind you that this is of the form the t derivative of u plus the x derivative of f of u is equal to 0. And if I do the derivative here according to the chain rule, this is going to be f prime of u times the x derivative of u is equal to 0. So in other words, f prime of u is just equal to u. So for this problem, f of u is equal to u squared over 2. So we got f of u is equal to u squared over 2. And so the condition xs prime of t is going to be the jump in f over the jump in u. So f to the right of the shock minus f to the left of the shock, u to the right of the shock minus u to the left of the shock. Okay, so what's going to happen in this case? For this particular, so this is a very popular f to have here, so I'm just going to do it generically. So we're going to have ur minus ul, and then f of ur minus f of ul. Well, f of ur is u squared over 2. So this is going to be 1/2 times ur squared minus ul squared over ur minus ul. Okay, so then we can see that xs prime of t is going to be equal to 1/2 times ur plus ul. So xs prime is equal to 1/2 ur plus ul. So in this case right here, for this Burgers equation where f of u is equal to u squared over 2, xs prime is given by this formula here. It's just the average value of u to the right of the shock and u to the left of the shock. Well, for this problem, u to the right of the shock is 1, u to the left of the shock is 2, so this is 3/2. Whoops. 3/2. So xs prime is equal to 3/2. So this tells us that xs of t is equal to 3/2 t plus a constant. We can figure out the constant by looking at where the shock starts. We know the shock in this case starts when x and t are both equal to 0, so it's just going to be 3/2 t. All right, so the shock location, the path of the shock is going to be xs of t is equal to 3/2 t. So that's x equals 3/2 t. So it's going to be a line. So it's not going to be a cool curve like I have there. We'll see a problem later that has a cool curve like that. So xs is going to be equal to 3/2 t. I can think about this as a graph. It's t is equal to 3/2 x. So it's t equals 3/2 x. So it's going to be a slope that is bigger than 1. T not t equals 3/2 x. T equals 2/3 x. So it's going to be a slope. I don't know why I'm having trouble with this all of a sudden. It's going to be a slope okay. It's going to be t equals 2/3 x, so it's going to be bigger. This slope here has a slope of 1/2, so it's going to be bigger than that slope and smaller than that slope. So something like this. Okay, and this is t is equal to 2/3 x. And so then what we're going to have happen the characteristics over here, whoops. Characteristics over here are going to be like that. These should be all straight lines. Forget about the bin there. Okay, and then we can write the solution in the following way. U of xt is going to be 2 over here. So it's going to be 2 over here. That's for, I could say 2 greater than 2/3 x. Actually, I'm going to, well, okay, it doesn't matter. T greater than 2/3 x, or equivalently, I could write x less than 3/2 t. And then it's going to be 1 over here for t less than 2/3 x. Okay, so for this problem, we knew the only 2 values of the solution were going to be 1 and 2. We just needed to figure out the precise location of the shock, and that's what we did here. Okay, so that is it for this video. In the next video, we are going to look at a traffic problem that also has a shock.